So who knows how HTTPS works? Or what's the difference between HTTP and HTTPS?
When you use certificates to encrypt it, so the first thing it does is exchange certificates, so it's all encrypted.
Yeah. So what is a certificate? Or maybe that might be too big. So can you say anything about what a certificate is, or how it works, or why you would need one?
Yeah, it verifies who you are to make sure you're a trusted source. There's entities on the internet that sell them, or you can use self-signed certificates. And then it utilizes that certificate to begin to set up the encryption that's going to be used for the rest of the session.
Yeah. So if you're a server, like a resource or a server, and you want to set up encrypted communication with a client, then you have to have a certificate. And as Jeff said, you can use self-signed certificates, which work just as well as certificates that are verified by a certificate authority. We'll talk about all that stuff in a second. But there's an issue of trust. We'll see that there's a lot of circularity. There's a lot of circularity in security generally when it comes to certificates or trusting or setting up encryption. How do you get started? So how do you know who to trust? There has to be some kind of starting point, but it's not obvious how you get there. So first thing we could look, I could just on GitHub, they have a certificate, so you can just check this out. So in Chrome, there's a little icon here. So the connection is secure, meaning that it's using a certificate. So you can take a look at the certificate, and here's the kind of the leaf node. So a certificate can be a self-contained thing, but they're usually chained. There's usually a chain of certificates that lead back to a what's called a certificate authority, or a root CA, certificate authority. So there are a small number of certificate authorities, and these are people or organizations that are officially trusted. And basically, it's just people who trust each other and say that you should trust them, and it's all kind of official, but somewhat informal. And these root certificates are usually located on your machine. So you actually have a bunch of these certificates on your machine, these root certificates. And what happens is when you visit github.com, and github.com wants to establish a secure connection with you, they send you this. They send you their certificate, and in fact, they send you a chain of certificates probably. And you start here, and then you check this and see it. Your browser checks and see it to see if this certificate is valid. And if it is, then it checks to see that the issuer is valid, and so on until it gets to the top. And this top certificate should be on your local machine, and it'll be trusted. And so if you can go all the way up the chain without breaking anything, then you know that one, you have a secure connection, and two, you have a secure connection to a trusted resource. So you can look at some of the details here. So a certificate is basically a form. It's basically a form you fill out, or that not you, but that a host fills out, and it gives you information about what this organization is, and it tells you who issued the certificate. There's a serial number. There's all kinds of stuff here. There's a whole bunch of stuff. And you can see on your computer, so on a Mac, you have this keychain access. So you can actually see, if you go to keychain access and then certificates, you can see that you have a list of all of these certificates. Which one is this? So the root digicert high assurance EV. So this is that certificate actually that I have right here. So my operating system has decided to trust this, and there are some differences. So Mozilla versus it's mostly standardized, but there are a couple small differences. So not every browser or operating system will trust everything, and this can be updated and changed. So that's the basics of how that works kind of at an administrative level. Okay, so now we're going to take a look at Wireshark, and we'll take a look at unencrypted traffic, and then we'll look at encrypted traffic just to see what the difference is. So I'm going to go to example.com. One of the few remaining non-certificate using sites. We'll go here, and I can start a capture. I'm going to choose my Wi-Fi, start a capture. I'm going to go to example.com a couple times. I'm going to stop the capture, and I get a whole bunch of stuff, obviously. So I'm going to filter this by HTTP. And you can see that, actually, maybe I should, we'll start with this. So HTTP, is this an IP address?
No. Maybe. I don't think so.
It definitely
IPv6 address.
Yeah. So it doesn't look like the familiar, 127.0.0, whatever we're using. So there's IPv4, which is what we're more familiar with, and there's IPv6. You can tell that there's a lot more happening with the IPv6. So you'll see a mix of both being used, but this is IPv6, and here is here's the client, my browser, making a GET request to this resource, and we can look at all of these things. So Wireshark will set this up, and this basically reflects the structure of network traffic. So I'll just scroll down to this image here. Where is this? So this is what's called the OSI model. It's a description of the different layers in the network, and these are all supposed to be encapsulated and kind of agnostic about any other layer. So the physical device is the lowest. You don't worry about that. Ethernet, this is the data link, and then network. And here we can start to maybe pay attention a little bit. And here is where we're really concerned. This is HTTP, basically. So this is typically what we care about when we're developing applications, but there are a lot of other layers underneath this. And all of these are abstracted away so that the HTTP layer doesn't really need to care about the TCP layer or the IP layer or anything like that. So if we look here, this basically reflects that structure. So here, the physical devices, right here, Ethernet, layer 2, IP, layer 3, TCP, in this case, layer 4, and then HTTP, the top layer. So there are different, some people talk about there being 5 layers or 7 layers, but yeah. So here, if we look at the HTTP traffic, we should be familiar with this from the HTTP server. This is all just bytes being passed in a particular format or protocol. So we're making a GET request, and we can see everything here. And the server is redirecting me here. Let's see. And you can actually right click on a particular packet and follow it. So this gives us that whole interaction. So I refreshed twice. You can also, I'm going to remove this filter. And we can see prior to this HTTP that there are other layers of the network operating first. So there's a lot of other stuff going on, but just these TCP packets. So here's that first GET request that I made. But before I made the HTTP request, there's all these TCP connections happening one layer below. And TCP connections, they have a protocol, so there's actually a back and forth that happens. So you make a request. Let me see. I think this is, yeah, right here. This thing that ends, IP address ends in 478E. This is the client computer. So this is the client computer making a SYN request. So it's basically that initial TCP request. It's a request to sync. And then there's a SYN ACK. So the server responds to the TCP connection. So it acknowledges and then sends another SYN request. And then my computer acknowledges that request. And then the TCP connection is set up. And once that happens, you can start sending HTTP traffic. So there's that back and forth that we don't really need to worry about, but there's a lot happening under the surface. Okay, so then what happens if we get an HTTP S request? I'm gonna go see filter. Go somewhere. Okay, so I go to Facebook. I'm going to stop this. Let's see. Try to find a filter that works with this. So this TLS, let me see if I can follow this one. Yes, there's a lot going on because I'm streaming right now, but the idea, so you still have the TCP connections, but instead of HTTP, you have this TLS connection. So TLS is the encrypted version. And if you take a look at it, you'll see that there's encrypted application data. So you can't actually see the headers or anything else. So you get what looks like gibberish. So if you're sending secured information, you're sending, let's say, your credentials and an authorization header, or you're sending form, your credit card information in a form. If you're sending it over HTTP, it's easily intercepted and it's in the clear. Whereas if it's encrypted, it can still be intercepted, but it's a lot more difficult to actually access the information. Okay, so we talked about certificates already a little bit, but we can actually create our own certificates. So here's a command. OpenSSL is the command line tool, standard command line tool you should have installed. And I could run this command, and there are obviously a lot of different options, but I can create my own certificate, my own public-private key pair. We'll talk about those in a sec, but I just have to fill out this form. So I'm just going to do and now I have just created a public-private pair of certificates. So here is what that looks like. Here's the public certificate, and this is the private certificate. So the way this works, I don't you can read in the README, but I don't really understand at any kind of depth how this works. But the problem with secure communication is that you essentially need to agree on some kind of encryption in order to communicate, in order to use encryption, right? So if there's a password or a decryption key or something, we have to both be using that in order to actually encrypt and decrypt each other's messages. The problem, of course, is that how do you get started? So if I'm over here and you're over there, how do we start sharing encrypted communication? So I can't just tell you, hey, use secret code, whatever, and then we start using it because I've sent that over the text. There's basically no way of doing that. But there is apparently some way using math stuff that I don't understand, and you can set up. It's called an asymmetric key. I think it works by getting two large prime numbers and doing some magic stuff. But so there's some way to bootstrap that initial communication. And once that initial communication is established, then during that exchange, so there's an exchange that happens with encrypted communication as well. During this exchange, there's actually not an asymmetric, but a symmetric key that gets agreed on after that initial exchange. So there's an exchange of certificates. The client validates the certificate. Then they exchange keys, and they agree on encryption and the key to use. So you don't have to understand how that works in detail. I don't understand how that works in detail, but that's how that works. And this is the basic mechanism. So this this is a public key. So this can be available to anyone. Anyone can access this. In fact, if you're a client, you need to get this from the server. Now, this private key, on the other hand, the server needs to keep this a secret. If this gets out, then it breaks. It ruins encryption for for everyone communicating with the server. So we can take a look at this. So this is encoded. You can also do this on the command line, but so I just pasted the certificate, and you can see that all of the information that I filled in is right there. Now, if I spin up a server somewhere and I put I load my certificates there. If I'm using Chrome or any other browser, basically they're going to throw up a bunch of, the screen's going to turn red. They're going to throw up a bunch of warnings, and it's not going to work, because even though this traffic would be encrypted, it's not trusted. So it's as Jeff said, it's a self-signed certificate, meaning that I made this in isolation and I didn't get official approval from the official sources. So the basic mechanism of the encryption is the same, but the kind of authority structure it is not. Okay, and then once I have these, you can actually start encryption. So if I'm a client and I get the server's public key here, I can encrypt traffic using that server's public key and then send it. And so that's how you're able to communicate. So there's more to there's some more in the README if you're interested in looking at this in more detail, but that's the basics. So here is what a certificate, it sounds very mysterious and it's kind of complicated, but at the end of the day, this is all there is to it. You get a public certificate and a private certificate, and then you use these to encrypt and decrypt traffic. Now for the challenges, it's kind of a two-parter. So one, I think we've kind of done this one already earlier, but you can, just to get practice with Wireshark, you can go here and use Wireshark and then try to figure out where the credentials are. So you pass in a username and password using the basic authentication scheme. So you'll have to figure out where those credentials are and how they're stored. And once you do that, then you'll have a local, you'll go in here, you'll have to set up this other node server in the challenge. You'll run the server, and initially it's unencrypted, and you'll do the same thing with Wireshark. It's basically just the same thing as this, except local. Once you get that working, then the real challenge is the second part right here, where you're going to you're gonna have to create a self-signed certificate basically, and then plug that into your server, and then use Wireshark and see if you can find the credentials. You can. This is so you can do this challenge with either Postman or the browser. It's probably easier to do in Postman because you'll basically have to close and reopen the browser a whole bunch of times as you're doing this. So it's probably easier in Postman, but either one is fine. And for this one, it's partly an exercise in looking in the documentation for something new you haven't seen before. So Express is another framework for handling Node, or creating a web server in Node. So you'll have to look through some documentation, but it should be doable. All right, are there any questions about that?
Chad, will this video be available later today for us to check out?
Yes, yeah.
How about the one for yesterday? Is that available?
Yeah, I didn't put that one up there, but I will. So yes, I'll put both of these up.
How about Saturday? Is that one available?
Yes, yeah.
All right, thanks.
Okay, any questions?